Hello everyone! In this series of 3 videos, I will show you how I designed and built this touch-sensitive USB-C powered heart-shaped board based in the ESP12F module. It became a beautiful RGB LED board with multiple and custom-made light effects, controllable with Home Assistant, a web browser, or by simply touching it. I will walk through the building steps from the electronic design, components assembly, coding and programming, the creation of a custom touch-sensitive sensor, and some errors and solutions. Stay tuned. Welcome to my channel. For the design process, I use EasyEDA as it allows not only design the boards but also connect to the LCSC to buy the components and JLC PCB to buy the boards. This is not a sponsored video though. I will briefly explain the principal parts of the boards. To connect the USB cable, I design a specific board in order to hide the connector. It only has 3 parts. 2 resistors to tell the charger we want 5 volts and that the top current is 3 amps, the solder connector to connect to the main board, and the USB-C connector. This is the 3D model of the board without the USB connector. In the main board, we can find the USB-C power only board to supply the 5 volts and the ground. Then these 5 volts are regulated to 3.3 volts to power the ESP. The ESP has the principal programming interface connected to a header with the reset, transmitting, receiving, GPIO 0 and ground pins. The board is powered from the USB when being programmed. Using the capacitive sensor Arduino library, I try to make the board touch sensitive. It works acceptably, but not without flaws. Therefore, if there is a next version of this board, I will migrate to an ESP32 which has built-in touch sensing, and I will use the USB not only to power the board but also to program it for the first time. The ESP controls the MOSFET circuit to turn on and off the power to the LEDs. This is because the datasheet did not specify the standby power of the LEDs, so I tried to minimize it by completely cutting it off. It turns out it is insignificant. The maximum current the main MOSFET can handle is 4.4 amps. This board can be chained together with more boards, so there are headers to do these connections. Keep in mind that the 3 amps from the USB can only power 3 boards. It is possible to chain more together using different USB chargers. The LED used is the WS2812B in a 5mm square package. The LEDs are arranged in lines. There is a connection missing between pin 7 of the ESP and the D-in pin, so a wire should be added. This is a 3D model of the board. These 2 pads are connected together, they are touch sensitive and together with the 4 holes can support the board. These are the finished boards manufactured by the JLC PCB. Look how well defined the heart counter is. Regarding the assembly of components, I will start with the USB-C power only board. By the way, you can find all the board's information in the links in the description. The assembly is very straightforward. Simply use a solder iron and a piece of tape to solder the components to the board. Assembly the components to the RGB art board has more steps. As I did not buy a solder paste stencil, I will dilute some solder paste with isopropyl alcohol and then apply the mixture with a syringe. You can find isopropyl alcohol in a common store as it is used in electronic repairs. Make sure to use a high concentration one as it leaves no residue. The important thing here is to get the solder paste inside the syringe, which can be challenging, so keep sucking the solder paste until the syringe has enough. Then press the syringe until solder paste starts to exit and apply it to the pads of the board. After the solder paste, it is time to put the surface mount components. I personally like to align all the LEDs to avoid any error during the mounting process. This kind of blue silicone pad is very useful as it allows you to distribute the different type of components by the all locations. Now it is time to solder the components. For this, I use a heating plate like the one presented. I bought it in a promotion for under 60 euros and it works like a charm. I really enjoy watching the solder paste melting. Next, I solder the programming header, but it is better to solder first the ESP module as the connector can limit the movements when soldering the ESP. This is the brain of the board, the ESP12F module from AI Thinker. It is based on the ESP8266, which has built-in Wi-Fi. Let's solder it. Now it is time to solder the two boards together. I use some painting tape to help holding the USB-C power-only board in place, and I made sure it was correctly aligned. As previously mentioned, there is a connection missing between the ESP module and the data in pin of the first LED, so it is necessary to solder a wire between the 7th pin of the ESP and the D-in pin of the in connector. Next, I solder some aluminum wire to the capacitive sensor solder pads to act as the support for the board and at the same time to be touch sensitive. First, with some sandpaper, I expose the aluminum. Then, I fill the solder pads with a lot of solder. The idea here is to put a wire in the middle of the solder. Be careful with your fingers, as it can get really hot. Repeat the process for the other part. Keep in mind that this wire is just for testing, as it is malleable. A more adequate support should be used as a final solution. After the solder part, I checked if there is an electrical connection between the wire and the board. Everything looks good. This is the final assembly. This is the list of the material used. The total cost in material was under 6 euros. Now it is time to move to the programming part.